Hi guys, we're doing a lesson on conduction this morning, and I have two assistants here that I am going to ask a few questions to, and we're going to watch what happens with some different materials in the melting of ice. Here we have two nearly identical tiles. They're different materials. We can ask what we think they are afterwards. But for first guys, I would like you to put your fingers on this one here for me, please. How does that feel?
Warm.
Warm? Yeah, I agree, it's warm. And then could you put your fingers on this one and tell us how it feels?
Cold.
Cold? Definitely cold. Okay, so we have a warm tile here and a cold tile here. Now, I'm going to say to you that actually they're the same temperature. How can we prove that? With a thermometer. Did you see how I used that earlier?
Yes.
Alright, so hold the digital thermometer, bang the gun, and aim the laser there. Oh, not in my face. On there. And then take it off. What does the temperature read there?
24.
24. About room temperature, actually. And let's do the same on that one. Let's see what it reads.
24.
24. So actually, they're the same temperature. But something's going on, alright? What is going on? Here we have a conductor and an insulator. A conductor and an insulator. Which is which? Leave that to the side for now. Let's get the ice. Oh no! Oh dear, the ice has gone on the floor. Classic. We have two pieces of ice. And we're going to put them on each tile and see what happens. We said this felt warmer, didn't it? We said that felt colder. Then we took the temperature and said that they were the same. But going from what we think in our minds that this is warmer, if we put the ice on each one, on which will the ice melt quickest? On the warm one. That's what we think in our minds. Let's try that out. If we could put a piece of ice on there and a piece of ice on there. Let's see what happens. Get the camera right in on those. Whoa, look, it's going completely off the tile. The ice on the colder tile is melting quickest.
What?
Why is it melting quickest?
I don't know.
I'm going to do this for you. Why is it melting quickest? Because we have a conductor and we have an insulator. Which material is this? What is that?
Wood.
That's wood. And this one?
Metal.
Metal. Metal is a conductor. Conductors can transfer heat more easily than insulators. And in this case, the ice is colder than the tile. The tile was 24 degrees. We know ice is 0. So the tile itself transfers its energy to the ice cube and it melts it. And eventually, the tile's temperature will go down and the ice cube will go up and they'll reach the same temperature. I would probably imagine that that is less than 24 degrees now, because some of the coldness has been sucked up. That's bad science there, actually. With the insulator, it can't transfer energy very easily. So none of the warmth, the energy from the wood, has been transferred to the ice, so it doesn't melt. I think that's the lesson over. There's probably more, but we'll leave it at that. Hope that helps.